Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, for part 4 of our food security series, we'll be talking to 2020 World Food Prize Laureate Dr. Rattan Lal about soil health. Dr. Lal's career has spanned over 50 years and nearly 100 countries, with a focus on holistic approaches to soil erosion, soil health, and climate change. What inspired Dr. Lal to go into soil science? What issues has his career addressed? And where are we with soil health and food security today? Answers to all these and more coming right up. But first, a quick thank you to our sponsor, Gasmet Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, carbon monoxide, methane, nitrous oxide, nitric oxide, nitrogen dioxide, ammonia, and water vapor in real time, simultaneously from static or automated chambers. Visit www.gasmet.com, that's Gasmet spelled Gasmet, or email sales@gasmet.com for more information. I'm your host, Abby Morrison. Let's talk about science. Hi, everyone. We are so excited to have Dr. Rattan Lal with us today. He is a 2020 World Food Prize winner from Ohio State, and he works a lot with soil science and soil health. We are so excited to have you, Rattan. How are you doing today?
I'm doing fine. Thank you so much for asking to be with you this morning. It's a pleasure to be here.
Excellent. We are so excited and honored to have you on the show today. So to get started, why don't we talk a little bit about how you got started with your science, maybe some of your just background and your career and education. Let's start there.
Oh, very nice. I grew up on a family farm in northwestern part of India, and therefore got interested in soil science from my very young age. I saw farm operations, plowing, weeding, irrigation. I experienced drought, low fertility, low yield, those kind of issues. So I had always interest in understanding more about soil. So when I got into my college, there was a choice to major in my final senior year, whether plant science or soil science. And I opted for soil science, although majority of the people those days in the 50s and 60s were more interested in plant breeding, plant improvement, but I interested in soil science and therefore pursued that. And I think it has been a very good decision. I'm glad I decided that. Soil science has been a very rewarding profession, and I find it stimulating and very pertinent to addressing not only the food production issue, but also the environmental issues.
Yeah, for sure. And that really launched you on a wonderful, prolific career, which brings us to, we wanted to make sure that we highlighted, you are the World Food Prize winner this year. We talked about that a little bit on our last episode about Norman Borlaug. But can you tell us a little bit about kind of the World Food Prize in general, what that experience has been like for you? I mean, how you found out or were nominated, anything like that? Can you tell us about that?
I did know about the nomination. It was a great honor, privilege. Ohio State nominated me. And so that was a very important part to be nominated by the Ohio State. Kind of gives you a very important stamp from a very well-known land-grant institution. So that was a pleasure. The surprise was that I received a call quite early on, several months ago. And at that time, I was not expecting anything like that this was going to be the information that I was fortunate and privileged to be the recipient this year. And so that was a very, very pleasant surprise. I was not expecting any decision at that point in time. Therefore, I wanted to make sure that this was not a kind of a joke. So I wanted to be sure that I was given a correct information, that this was real. I was assured, yes, it was correct that I was the 2020 World Food Prize Laureate. So it took me a few minutes to grasp the significance of this. Once I realized that this was a correct, real thing, I was told that I will be the 50th recipient, and it had quite a lot of significance. Number one, I'm the first one at Ohio State to receive that award, so that's a great distinction. Number two, it is the 50th anniversary of Dr. Norman Borlaug's Nobel Prize. You remember he received in 1970. And number three, it's a 150th anniversary of the Ohio State. So it was really a triple win situation. I'm the 50th laureate, first time in Ohio State, 50th anniversary of Dr. Borlaug's Nobel Prize, and 150th of anniversary of the Ohio State. This is really a great, great privilege, honor, and something I'm grateful to everybody who made it happen. World Food Prize Foundation, Ohio State, colleagues and friends from around the world for their support. This will be remembered in my family for generations to come. Thank you all very much for that.
Yeah, wow. I didn't know about the 150th anniversary. So happy birthday, Ohio State.
Yes.
Yeah, wow. What a great honor and what a privilege to have you on the show. Thanks again for taking the time. We started looking into a lot of the work that you've done in preparation for this interview. And really, you have had this very broad-reaching career. My colleague DJ that you've been working with for an article in our members magazine, CSA News, said you've been to like 99 different countries for your work, and just huge list of accomplishments. But I wanted to focus in on kind of three different areas of science that you have focused on throughout your career. So I was hoping you could dig into those a little bit more. The first one of those is combating soil degradation. So can you talk about your work or breakthroughs and discoveries that you've had in doing that research?
Thank you. Thanks so much. That's a good topic. I started my first professional job after finishing PhD and postdoc research in Ibadan, Nigeria. I joined there in December 69. That's more than 50 years ago now. And very first experience I ever had was on soil erosion of a plowed field in April of 1970. And we had a plowed plots and corn planted to see the time of planting and method of planting, like ridges versus flat seed bed with mulch and no mulch. And to my surprise, even though the land was terraced, we had rainfall, probably 4 or 5 inches of it came at a very high intensity, like 6 inches per hour. I had a recording rain gauge nearby. And I had never seen such a devastating soil erosion. Seedlings were washed away, ridges were washed away, and the distance between the terraced upper and the lower was hardly 15 meter, 20 meter maybe at the most. And that was an experience. And the worst was that these soils where I was working, the top soil layer was only about 8 or 12 inches at the most thick. Beneath it was a very dense gravelly horizon, quartz gravel concretion embedded in clay, not a very good media for root penetration. So you had only top 8, 12 inches of soil, and most of it is being lost in first few rainstorms. That was a very serious challenge, and therefore my interest was how I could stop soil erosion. That was one part. After a very heavy rain of 4 inches, a few days after that, like 2 or 3 days after that, you go in the field in the 2 o'clock in the afternoon, and you notice corn plant wilting very badly. Gee, what happened? All that rainfall, and in 2 days, 3 days after, so the soil water holding capacity was very low. soil was not holding water. And once the soil got very dried, it set hard and very compact and crusted. So physical degradation, I'm not talking about chemical properties, pH or nutrient or other chemical issue. I'm strictly talking about the physical structure, compaction, erosion, high soil temperature. Now that the soil has low water, soil temperature in the top 1 to 2 centimeter depth could be 50 degrees Celsius in the afternoon in April, May, early June. So here was physical degradation problem, which are very different than the chemical nutrient depletion. So even if you broadcast fertilizer, they were not effective. You apply them, they are not effective because either they are washed away or volatilized or soil physical condition, high soil temperature, low water content, drought were very serious problem. So that was my challenge, how to overcome these serious soil physical constraints. And that was a steep learning curve for me. For a young person, very first job, and faced with a very serious challenge.
Sure. And you also worked with mined lands in that period. Is that correct, or was that later in your career?
That was in Ohio. I came back to Ohio in the early 90s. Then Ohio has, two economy, agriculture and mining. So mine land degradation and restoration I did in the 90s when I was in Ohio.
Nice. Okay. So yeah, I love this because I find that a lot of our guests really have these kind of foundational experiences early on that Norman Borlaug during the Depression saw a lot of those issues, and you having kind of this foundational experience of just seeing something devastating and difficult and hard that really helps shape a lot of the rest of your career. I know you have this very holistic approach to soil health. So I love that. And another piece of that then is not just the actual physical qualities and erosion, but also then on the flip side, kind of increasing soil health properties. So can you talk about that?
Well, the other thing I should mention is that in a way, during 70, when I was working in Nigeria, professional colleague that I could reach out to for guidance and advice, there were not many. In fact, in 14 countries in Western Africa, I counted at that time, there were only 1 or 2 people with a graduate degree in soil physics, for example. So there are not many professionals. So you are in a way on your own to do whatever you can, read the literature and so forth. But one thing I observed that the plots which were covered by either natural vegetation like forest, or we had mulched them to keep the soil cool and moist, they were not affected by erosion. So my immediate observation, I took a lot of pictures at that time, if the ground is covered and even if it was plowed and you covered it back, soil erosion was not as serious. So my next set of experiment was, how do I keep the ground covered? So one approach was not plowing and keep the crop residue, leave detritus material, weeds, etc. On the ground. And the other thing, when I was comparing then a plowed unmulched surface and a untilled mulched surface, major difference between the two was the earthworm activity. At that place in Western Africa, earthworm were characterized by costs. As they burrow through the soil, they eject whatever they are eating. We call that worm cast. And so the surface of a mulch plot will be covered by worm cast, some of them fresh, wet, the others from 2 or 3 days old. And they are also very resistant to erosion because they are cemented together by some of the body products and waste that come with it. So looking at the soil health point of view, here was a mulch soil covered with a lot of worm activity and termites, centipedes, millipedes, and soil is very fluffy and healthy compared with a plowed bare ground, which is crusted, compacted, eroded, and very hard. So the question was uh, the soil health part of the biological management system, which these days we call regenerative agriculture. So the soil biological activity by mulching, by no-till, which we call now conservation agriculture, was far superior than a bare ground plowed surface, which was crusted, compacted, hard. And these results are also effects were also obvious in crop performance and crop yield. So my interest in soil health, although I'm a soil physicist, goes back to those observations. And at that point in time, I actually made movies by using cameras, movie cameras, and professional photographers to see the impact of earthworm activity on soil health, impact of termites on soil health, impact of ants, which are rather vicious. They can actually bite you pretty badly if you have very close vicinity to them. But I made movie on these organisms, how they affect soil quality, soil health, and functionality, and all of them very positive impacts. So I became very interested in biological systems to improve soil physical health. That soil infiltration rate, water retention, porosity, erosion control through biotic mechanism. I became fascinated by this. So my first book I ever wrote was on earthworm, termites, ants, and soil biological property. I call it tropical ecology and physical edaphology, but that was the basis of it. I had a chapter on earthworm, termites, centipedes, millipedes, different chapter on different, and how plowing, burning, other adversely affect soil health. So it has been a great experience.
Man, there is so much in there that I was just like, wow, it's so exciting and cool. I mean, I love the use of, the media with the movies. I think is awesome. I love writing. I love writers. So I'm just like, yay, anytime I hear about book writers.
I should acknowledge here the movies which I used to show to my classes also were really facilitated by United Nations University. They saw my work and they sent their photographer to produce 4 movies. One on deforestation impacts on soil health and climate change. At that time in the 80s, we were already looking at the impact of deforestation on microclimate and mesoclimate and other things. Second movie was on earthworm. Third movie was on termites. And fourth movie was on soil erosion. So I made 4 movies with the help of United Nations University.
Oh my gosh, that's amazing. Are they still like available? Like can people get them? Is it just part of teaching or?
I do have a set, but United Nations University may have. I do not know, but they may have. But I once in a while show them to my class. They were still the traditional, those. You may not realize that the rolls, the film, like
Oh yeah.
tape, and then I think I have now a kind of a modern video model of it, but they are still not digitized. This was 83, 84. That was 40 years ago.
Oh wow. This is so fun. Thank you so much. And thank you to the people that made those possible. So you did mention in there, you also mentioned climate change, which is kind of the third big category that you've done a lot of work with. So can you talk about that as well?
Well, yes, that's a very good point. And these are all interrelated, by the way. There is no boundary between them, soil degradation, soil health, and climate change. They are so interrelated. And this is what the nexus thinking, the holistic thinking comes in. Soil health, the determinants, as if you remember what I mentioned, earthworm, termites, and other soil biota. And earthworm, termites, biota thrive under mulch plot because that is a food for them. Mulch is what they eat. And of course, they can drag it into their burrows, and they also incorporate that soil organic matter inside the soil where they habitate. So, and as they consume that mulch as their food, they eventually transform into humus. So soil humus, or the soil organic matter content, is very integral component of soil health on one side, because if that decreases, then the soil becomes degraded. So on one side, it restores the degraded soil and sustains its health. On the other side, the carbon that would have been emitted into the atmosphere by erosion and by degradation is now incorporated into the soil. So I became very interested how soil carbon improvement, restoration, increase can actually do adaptation and mitigation, both, of climate change. Adaptation because now soil health is better. So there's a better soil moisture content. There is a better nutrient cycling. There's a better soil structure. Soil biotic activities are keeping soil porosity in a very good shape. And at the same, so the plants are adapted. The drought is not as severe because moisture is now conserved. So in a way, this was climate smart agriculture, which later on now we call climate smart or climate resilient agriculture. But at the same time, it is taking carbon dioxide from the atmosphere through plant photosynthesis, and you return the plant residue back on the surface as a mulch to prevent erosion. Mulch gets incorporated in the soil by biotic activity as humus, and as humus, it is preserved as a soil organic matter content, so it mitigates climate change. Now soil is a sink for atmospheric CO2. So during the early 90s, I became very interested in soil as a reservoir of carbon to mitigate climate change. So in collaboration with many other colleagues from NRCS and ARS and other land-grant universities, we really started working together and evaluating what is the carbon sink capacity. How much carbon can you store in soil? What are the cultural practices which can lead to carbon storage? So a whole new subject all of a sudden emerges for adaptation and mitigation of climate. So soil and agriculture then, rather than being a problem causing climate change and environmental pollution through erosion and through eutrophication of are now a solution to those problems. And that changes the whole ballgame altogether. Agriculture and soil as solution to modern, current 21st century global issues. Climate change, water quality, sedimentation, biodiversity, all of them. Soil is the solution.
Hey friends, I hope you're enjoying the show. Interested in learning more? Check out the feature on Dr. Lal in the October issue of CSA News. You'll find a link to it in our show notes, and it will be freely available for the next 2 weeks. If you are a certified crop advisor or certified professional soil scientist, you can also take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again to our sponsor GasMet Technologies. Conduct greenhouse gas flux measurements in the field using the GT5000 Terra. Weighing 20.7 pounds, splash-proof IP54 rated, internal pump and battery, and vibration resistant, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork. Visit www.gasmet.com or email sales@gasmet.com for more information. Thank you for being our sponsor. let's get back to the show. I love that. I just love it. I think it really just, it speaks to just, you said these are all kind of interrelated. And so I love hearing about research that really, does take from all of these different disciplines, which is obviously something you're, very familiar with in your career of kind of tackling all these different issues. But also just like use the earth wisely and treat it well. And, it'll, sometimes it'll help take care of itself with like all the earthworms and termites and that you were mentioning. But also just, like don't push it too hard.
This is, Abby, the basis of what we call nature-based solution. So you are really trying to work with nature to address those issues rather than fight nature. And I think that is one part which becomes very important, that let's try to mimic nature, what nature does. Nature, under natural vegetation, keeps the ground covered. It has a lot of biotic activity. So the question is how to adapt that natural system into agricultural system. So that's one part which really emerges from it. The other part, which is talking about connectivity, that all these processes are actually interconnected. So when you improve soil health, that leads to improvement in productivity. It leads to improvement in the nutritional quality of the food produced. It leads to climate resilience. It reduces water contamination and transport of pollutants into natural water. And of course, it also takes carbon from the atmosphere and puts into the soil. So the entire thing becomes a very natural process, which nowadays we call regenerative agriculture. So the basis is really very simple. Just see how nature does and try to work with nature.
Yeah, work smarter, not harder.
Yeah, work smarter. Yes. Yeah.
Great. So that's kind of an overview of what you have focused on throughout your career. I wanted to take a quick second and like, what are some of the biggest takeaways that you have found? I mean, obviously you've been at this for, 50 plus years, which is absolutely amazing and still going strong. So thank you for that. But like, what are some of the biggest lessons that you've learned, biggest takeaways that you've had?
Oh, thank you. Thank you. In a very simple way, one just from where we left in the previous, and that is I've been using that as a slogan or my flagship: the health of soil, plants, animal, people, and the environment is one and indivisible. That's one very important takeaway. And I think the past civilization, if we could talk to Mayan and Incans and Mesopotamian and Indus valleys and others, which vanished once they were thriving, they would say, we wish we knew that, that we would not have perished if we could have adopted that. And I think that's a very important lesson. We should make sure that the health of soil, plants, animal, people, and the environment, climate change, whatever, they're all interconnected. When one goes down, soil, the base foundation of everything, when that goes down, everything goes with it. That's one part, takeaway. The second, which is corollary of that, people are mirror image of the land. When land is degraded, people are obviously in not good shape. And on the other hand, when people are hungry, miserable, desperate, they pass their sufferings to the land. And the land reciprocates. And this vicious cycle of people passing their suffering to the land and land reciprocating, this vicious cycle eventually leads into terrible situation. You can drive through, let's say, Caribbean, Western Africa, Sub-Saharan Africa, South Asia, and other countries, and see the landscape, and you can predict the well-being of the people. You can drive through Western Europe, North America, you can see the landscape, and you know the well-being status of the people. So that relationship, people are mirror image of the land. And that is a very important lesson to take away. So somehow or the other, we should really make sure that the land and people are on a grading path, improving path, restoration path, and not a degrading path. So that would be the second thing I would say is very important takeaway. The third thing is degradation of soil takes maybe one or two rainstorms or dust storm, but restoration is a very, very slow process, very slow process. So the strategy is do not adopt preventive measures. Do not wait for restorative measures. Prevention is always better. And that means do not take the finite, fragile soil resources for granted. They are finite, they are fragile, and they are very easily degraded. So make sure that that doesn't, we never ever take them for granted. The fourth thing I should mention that sustainable soil and agriculture are and must be made solution to the environmental issues. So the question really is how to reconcile the need of growing and increasingly affluent human population with the absolute necessity of restoring and improving soil health and the environment. It's not a question of either or. We must have both. And the last thing in that connection is that when we have improved variety, Dr. Borlaug and many of his other colleagues, Swaminathan, Dr. Gurudev Ghosh, and many others, they promoted plant varieties, seed-centric approach. The seed-centric approach was excellent in the 60s and 70s, but now we know that even the seeds of improved varieties cannot do miracle if they are not grown under healthy soil conditions. Therefore, maintaining soil health is crucial to have continuous green revolution, evergreen revolution. If you want to call it the second green revolution, the soil-centric revolution. And I think that is the message that I would like to leave with my colleagues in soil science and agronomy and plant breeding, that we need to work together. And secondly, to the policymakers, that we need their help to translate science into action, that they go together.
Wow, there is so much in there. That was such a rich, profound answer. Thank you so much for that. Yeah, I like that idea of an evergreen revolution of, it's not just like a one-time solution. I love that. That is so wonderful. I got like chills when you were talking about just that connection between, people and the health of the land and needing both to be healthy. So thank you for that. Wow. So touching. So then obviously, keeping in mind kind of this evergreen revolution and this need for continual restoration and prevention and all of those things, where do you feel that we are today on some of these issues, maybe compared to when you started, as well as like what are the next steps that we need to take to keep going on this improving path towards greater soil health and food security?
Oh, thank you. I'm glad you asked that question. And one thing I like to mention from the very beginning, that farmers throughout the world, industrial large-scale farming, as well as 500, 700 million small landholders who farm only 5 acre, 10 acre, that kind of land area. And there are many of them, and they produce majority of the food in developing countries and elsewhere. They are the stewards, the greatest stakeholders in the stewardship and management of soil and natural resources. Therefore, we must empower them somehow to make sure that they can keep the soil and natural resources in the best condition possible. So empowering them, and one way to empower them would be to incentivize them for doing good things through payments for ecosystem services. This is not subsidy. This is not charity. This is not handout. We are asking them to address global warming. We are asking them to address water quality, algal bloom, drought stress. We are asking them to increase biodiversity in soil. Soil, after all, is more than 25% of all terrestrial biodiversity in the soil. They are the greatest steward, tenant, stakeholders of that. So empowering them, and many of the small landholders, even the large land, are women. So empowering women at the same time would be a very good strategy to follow. While we are doing that, we can also provide them technical knowledge about how much carbon sink capacity is in their land and how that sink capacity can be achieved by providing them the information on rate of carbon sequestration. And that rate of carbon sequestration lead to the next topic of importance, farming carbon. By what I mean by farming carbon is we are used to it in the Midwest, farming corn and soybean, and in Madison, Wisconsin, farming dairy animals, and other places, other kind of beef and pork kind of produce. Farming carbon also is a commodity that you can buy and sell in the market. So it could be another income stream for farmer. If carbon can be traded as a commodity, it becomes a marketable produce from good farming. And we should encourage farmers to do that. We should encourage industry entrepreneur to make carbon farming a marketable commodity. So that's the second part, which I think, third part, which I would say take away in addition to payment to services. The fourth part I'd like to mention is something to do with protection of the soil. We are almost 7.8 billion people now. We are destined to become probably close to 10 billion in another 30 years by 2050. And that's a large population. I read a report recently came out from Washington State University that perhaps the population will not become 11.4 billion or so by the end of this century, but maybe it will begin to decline very soon. I hope that report is true. But what I'm trying to drive at is that the protecting soil is a great idea because soil resources are finite. And soil is not just for agriculture. Soil has many, many functions, many functions. Many of them we do not even know yet. For example, soil is the major, so 95% of all the antibiotics come from soils. The antibiotics that humans take and the livestock take. So soil beyond agriculture, soil beyond fuel, and soil beyond fiber, soil has many uses, and therefore we must protect the soil. That brings me to the question of rights of soil. Rights of soil. Soil, as I mentioned, is a living entity. When it dies, because there are no earthworm, termites, centipedes, microbes, because of the misappropriate use of soil resources, dumping of chemicals indiscriminately, or plowing or burning crop residue and things like that, we obviously lose those organisms. And there's already a very serious report that between 1970 and now we have lost more than 2/3 of the biodiversity. Just a report came out. So protecting soil is very important. We have in this country through EPA Clean Air Act. We have Clean Water Act. We have no Healthy Soil Act. I submit that there is a very daunting challenge to maintain clean air and clean water without having healthy soil. Environment is a trinity of three things: soil, water, air. You can't have a clean water and clean air without having healthy soil. So I think it's about a time to think about in a farm bill where we talk about payment of ecosystem services, empowering farmers and land managers for mitigating climate change and using soil as a media to improve the environment. It's a time to put in Rights of Soil Act. So those farmers who do good thing to make soil as a solution to environment, make agriculture as a solution, they should be rewarded and soil resources protected against misuse and abuse. That would be very important part. The last thing I would like to mention in that is education. We talk about all kind of education, reading, writing, math, and so forth, science, chemistry, physics. We never talk about having our children from right primary school getting their hand to feel a rich, fluffy soil, what it feels like. And I think it is also good for children to get used to where the food comes from. Many times people ask, where does the food come from? Answer is grocery store. No, food comes from soil, stupid. That's where it comes from. So they should know very immediately the feeling of soil. And education at all level, education of general public, education of policymakers, you might want to call education of religious leaders. We talk about differences among religion. I think we should be talking about commonalities among religion. And one thing which is common amongst all religion, well, Judaism, Christianity, Islam, Hinduism, Buddhism, you name it, Sikhism, stewardship of soil and natural resources is common amongst all of them. That commonality should be highlighted by all religious leaders. I'm really, really very fond of Pope Francis. He has highlighted the stewardship part on natural resources, especially soil, very, very highly. So I think this is an important part to follow up. I would also mention that in the era of pandemic, which the world is passing through, which is a very serious tragedy, which had disrupted food production and supply chain. It has really put sustainable development goal probably 2 decades behind already by disrupting the economy and causing a lot of looking at the local food production system through improvement of soil health in urban agriculture in peri-urban area is probably one option to overcome the disruption caused in food supply chain globally. So those are some of the things which I think are emerging global issues, which I hope we'll pay attention to.
Yeah, those are all great things. I know since starting working here, like this year, I started growing some of like my own plants just to like learn because I mean I'm definitely. I understand. I mean, being in Wisconsin, like I'm around farms, but like I don't know a ton about how they work. Like I'm getting better at like identifying the different kinds of crops that I drive by because for a long time I just didn't take the time to know, and it's been very enriching in my life to learn about it. So that's great. I definitely encourage people to learn more. But on that note, actually, I have 3 questions left for you. It has been such a privilege and joy to be talking to you so far, but I don't want to take you all day. So first of the last questions is, if people do want to learn more about these issues, if just about any of these topics, really, where can they go to learn more?
Well, Soil Science Society, America headquartered where you are, Madison, Wisconsin, and the Tri Society is organization like that are really very good source. Many of the websites and many of the fact sheets are available through society, professional society. I have been president of the Soil Science Society of America. Very fortunate to be elected and serve in that capacity. I am still past president of the International Union of Soil Sciences. I put out my quarterly viewpoint. When I was president, I did a monthly viewpoint on International Union of Soil Science. Right now, I put my quarterly viewpoint on that. So these society have information. There are a lot of videos available. Just to give you an estimate, the World Food Prize was announced on 11th of June. And as of today, I have given 40 webinars, 40, about 3 a week kind of average. So this is a great privilege. World Food Prize gave me a great platform to be able to share my opinion and suggestions, and that's a great thing. Scientific literature, science is a good place to find for people who are scientifically oriented. One of my article in Science, which was published on climate change and food security, which we were talking today, as of today, it was published in 2004. It has 6,000 citations. The downloads of abstract is hundreds of thousands. PDFs are several thousand, like 30, 40,000. So some good article, not only just mine, many others exist. There are YouTube videos. I gave a talk at Gustavus Adolphus College in Minneapolis, Minnesota, St. Peter, small town. And that YouTube video is very, I even watch myself sometime. It's very nice. And many others are available from other scientists and colleagues. So there are quite a lot of good sources. Media sources, quite a nice one to see. Educational book, for example, there is a book for children, Essays for Soil. And I am also co-editor of a book coming by International Union of Soil Science. It's in print right now on education for primary and secondary school children about soil and ecosystem services, some of those things that we are talking about. So we need more of those, but some already exist and can be accessed.
Excellent. Those are great resources. I also want to highlight a few that we have access to. So first, we will be publishing an article in CSA News soon that is going to actually be on you as the topic. So if people would like to learn more about Dr. Lal, they can definitely check that out. We'll include links to all of these in the show notes. And then also your colleague Maggie sent me a bunch of YouTube videos, which kind of give some really nice summaries and overviews of some of the things that we've talked about today. So that's great. And then also the World Food Prize website itself has more information about Dr. Lal and his work, and also the prize itself. If anyone is interested in learning more about that, it is an awesome program with lots of opportunities for people across like all levels of experience and education. Second question for you is, if people want to then take that next step to get involved in some of these issues, what can they do to take those first steps?
Well, that's people can make really a big difference. And many times I'm asked, I'm only one, I can only do small thing. We human are both culprits and victims. And I think even a small incremental change in our values, in our thinking, in our lifestyle, in our caring attitude toward nature and soil and natural resources, multiplied by 7.8 billion means quite a lot. So nothing is so small. Even a small savings of energy, switching off the lights when you're not in the room, maybe adjusting your heating or cooling thermostat by 1 or 2 degrees over a year can make a difference. Having a simple clothesline in the basement, maybe, where you can save some energy for drying some of the heavy clothes, can save that energy. Bicycling wherever possible, walking short distances, taking steps rather than elevator, can make a very, very big difference when you talk about our entire population. Our attitude toward food wastage. We in the US waste probably 30% of the food. Developing country, the food wastage is even greater because of the storage facility. So if we can save food from waste, 1 kilogram, 1 pound of food saved is a lot better than 1 additional pound produced, because wastage lead to taken to landfill, lead to emission of greenhouse gases, pollution of water, and many other issues. Plus, of course, additional energy and resources. So we can really, really make a big difference, even small things. We should all try to find out from our own assessment of environmental footprint of our lifestyle. And I'm not going to name anything because that's a very personal thing how you do. But even reducing our carbon footprint, water footprint by 2% every year for next 5 years, if we make that a plan, can really make a big difference when you multiply that by 8 billion people. So we ourselves, which are culprit and victim, can become solution and beneficiary through our own better attitude. And I would very much like to suggest that. And while adopting that, we should try to educate others about those, especially children. We can become a role model for children and make sure that we explain them the benefits of protecting nature, saving, not wasting water or food, and not throwing away. The throwaway society culture, we should give up as much as possible. And of course, we should encourage general public in the same mode. So yes, we can make a big difference. Our thinking, our attitude, our value, our adopting habits which are pro-nature habits can make a whole lot of difference. Please remember, we have only one planet. This is it. This is our home. And we must safeguard it, cherish it, protect it, and enjoy it.
Absolutely. Yeah, that's wonderful. Thank you for that. Final question for you is, if people only had your research, what is one fun fact that they wouldn't know about you?
Oh, very good. You already stole my thunder. You said you like gardening. That's what I like. I have a garden and I grow vegetables. I love working there at least 1 hour a day. I really enjoy looking at the plants grow. I was thinking of planting fall vegetable yesterday. I didn't. I wanted to plant carrots and some spinach and broccoli and really. Maybe not in Wisconsin, but in Columbus, I could harvest really until early part in December, first week of December. So, but I grow a lot of vegetable. Right now, I got some eggplants and I got a lot of squash, different kinds of squash. I got okra. I have beans. I got string beans, of course, tomato and bell pepper and chili pepper. And I have planted about a month ago radish, daikon radish, this long white radish. And I got quite a lot of that because it will loosen up the ground. And also, when I say mulch increases earthworm, gee, it sure does. I got 4, 5, 6 actually bales of wheat straw mulch, and I have almost 4 inches thick layer of mulch on the ground. So I practice and see what I teach and what I write about. And when I trying to seed a new crop and I use my little trough, earthworms come with it, and I hate to destroy them, disturb them, but try to put them back as much as I can. So it's really a living laboratory, this garden. Even when I have an hour lunch break, I get out of my desk and walk into my garden and go to see the plants which I planted yesterday, or irrigated them, or trimmed them, how they are doing. They are a very good companion to look at, to watch. And sometimes I talk to them, hey guys, do better than what you're doing. And they listen, they pay attention. They know I'm a friend.
That is wonderful. Oh my gosh. I do not spend nearly that much time, but I also am only growing herbs. I was like, I need something that I won't kill. So I heard they were easy and they've been doing okay. So maybe I'll work my way up.
And I think it saves quite a lot of, we get fresh food. I like cucumbers and fresh. So sometimes I just tell my wife, hey, wait, I'm going to go pluck something from the garden. And that's how it is. It's really, and even if you do not have a garden and you live in an apartment, having things in a box or in a small container, and I do have some plants in containers. I'm talking about tomatoes and eggplants and cucumber in container. And it's a very good idea to see plants grow. And it's very therapeutic.
Yes, yes. It's very satisfying to be able to put something in your food and be like, I helped this to live. Or at least didn't actively, accidentally kill it, as I have done with other plants.
Right.
Well, thank you so much for being on the show. It has been such a pleasure and honor to just be able to partake in your wisdom and knowledge. And my heart feels so full. So thank you so much for being on the show.
Thank you, Abby. Thank you for having me.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe and don't forget to rate and review us on Apple Podcasts, Podchaser, Stitcher, or anywhere else you find your podcast if you like our show. We are also available on Lyceum, the world's first audio learning community, where you can join our discussion group and comment on each episode. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.